Okay, today we will start with elementary matrix. Now, what is elementary matrix or how you obtain your elementary matrix? Elementary matrix is obtained while you are applying a single elementary row operation from an identity matrices. Okay, so identity matrix, you already know that it will be a square matrix, right? Okay, now what does it mean by single elementary row operation? Okay, so single elementary row operation will be there will have only one elementary row operation to be done at one time. Okay, so it can be either interchange by the row, it can be scalar multiply or multiplying with your scalar. The k here can be any value as I mentioned earlier. Okay, so it can be positive value, it can be negative value, even a fraction. Okay, addition or subtraction. Okay, you can have negative k as well. Okay, so uh, let us proceed. I think this one nothing more than that, right? Because I actually already highlight previously. Okay, so look into it. Okay, this is actually in your notes, huh? Okay, you can turn to the folder named mind map. Okay, so the mind map folder or the document itself, actually I have already compiled all the summary of the respective topics involved or the subtopics involved, so that will be very interesting if you're able to understand it well. Because for me, for mind map, you only need the mind map to have your revision, then you're able to score already. Okay, so without further ado, let us continue. Now is elementary matrix. Okay, elementary matrix is based from what you have under your elementary row operation. Now, let's say that you have reducing your matrix, your existing matrix, to a result. Okay, so from the process, you are involving two elementary row operation. Is that okay? So let's say this is 2 by 2. Okay, this is 2 by 2 matrix. So what will be your E1 then? Your E1 will be 2 by 2 as well. If let's say this is a 3 by 3 matrix, so your E1 will start with a 3 by 3 elementary identity matrices. If 4 by 4, then will be 4 by 4 matrices. Okay, it depending on what size of it. Okay, the size of it. I think it should be okay, right? Okay, so let us continue. Now, since that, imagine this is 2 by 2, okay, it's 2 by 2. So what you need to do is the first elementary row operation will apply your E1 here will apply the first elementary row operation that you have used at the first place. E2, same thing, you'll use back the original identity and apply the second elementary row operation that you have used for the second stage. Is that okay? And the inverse is based on the elementary row operations that you have. Okay, what it is? I give you an example. Okay, so I already highlight at the bottom here. So imagine if let's say your elementary row operation here is happen to be interchanged between row 1 and row 2, for example. So your first inverse elementary row operation or your first inverse elementary matrix will be the same. Will also row 1 interchange with your row 2. Is that okay? Okay, so if let's say your row 2 here is happen to be a scalar, let's say we have 1 over 3 R2 happen to R2, for example. Okay, so what will be your inverse elementary matrix? Okay, will be 3R2 happen to R2. Because if let's say your elementary row operation is on K, so your inverse elementary operation will be 1 over K. Is that okay? If let's say your K is, let's say, negative 2, R1 happen to R1, for example. Okay, so your inverse elementary row operation will be negative 1 over 2 R1 happen to R1, just like that. Okay, it depending on what you have for your elementary row operation. Is that okay? Okay, so let us continue. How if for addition then? Okay, for example, if let's say your elementary row operation happen to be, let's say, here, let's say you have R1 or R2 minus 3 R1 happen to R2, for example. Okay, so your inverse elementary row operation will be R2 plus 3R1 happen to R2, because this is negative 3 or minus 3. So that's why you have plus 3, just like that. Because plus become minus, or positive become negative, or addition becomes subtraction, just like that. Is it okay? I'm sure clear with this, right? Okay, let's say that this is happen to be R2 plus R3. So end up, your answer will be minus. Okay, because this is positive or plus. So end up here for inverse, you will have minus. Okay, so as a conclusion, what you will have as a conclusion is based on how many elementary matrices you have. In other words, how many elementary row operations you have. If let's say you have 2 elementary row operations involved, so they will have 2 elementary matrices involved. If you have 3, then you will have 3 E1, E2, E3. Is that okay? So if let's say based on this example, for example, so your answer will be E2, E1A as a conclusion, because you have 2 elementary matrices involved, then multiply with your A. Is that okay? Okay, and do remember A2 start first. Okay, 2, 1, and so on. Okay, if let's say you have 3 matrices, elementary matrices, so you have A3, E2, then E1A. Okay, I hope you can understand this. Okay, thank you.